and good afternoon to the attendees who have joined us and those who are still joining in. We do welcome you to this IITPSA Special Interest Group webinar. Our guest presenter today is well known to many of you, Mr. Singh. John is a member of the IITPSA Board of Directors. He's also the chairperson of our Audit and Risk Committee. But today appears before us as the chairperson of our special interest group in blockchain and Bitcoin and whatever else ticks the buttons. No, I'm just kidding. John works for the Spar group and he can further introduce himself in that regard, but he is well known to us in respect of blockchain and Bitcoin, and we do thank him for the time he's taken to prepare for this webinar and for sharing his knowledge and expertise with us. So without further ado, John, it's all yours, man.
Thank you, Tony, for that warm introduction, and thank you everyone for attending the presentation. So this presentation is a little bit different for me because I'm not only doing a PowerPoint presentation, but also doing a little bit of a practical aspect where I log into a AWS server and try to show you payments using a Lightning Network. So pretty exciting times for me, and I hope it works out quite well, and hopefully you forgive me if there's any glitches along the way. So I think just to sum up what this presentation is about is just to understand how the Lightning Network actually operates and to do a practical example of how to set it up and to do a payment. And when I first started out looking at this, my initial idea was to use the Raspberry Pi and try to set up a Lightning Network node on that. But surprisingly enough, Raspberry Pis are very difficult to purchase in South Africa because there's just never any stock of them because they're so popular. My second attempt was to actually take down some Lightning node software, recompile it, and try and build one up from scratch. But my technical skills failed on that one, and I finally got an option where I was able to use Docker containers and was able to set up a network like that. So that was relatively easier to do. So we will go through how I went about that and just explain a little bit about the Lightning Network in the process as well. So in terms of contents, we'll just do an introduction to Lightning. We look at the architecture of this test network, and then we look at some of the Lightning Network command line. So we will use Lightning Network command line to carry out various operations. So we'll take a look at some of them and what they actually mean, and then the actual physical demo on an AWS server will be done. So that one should be quite interesting because it's going to be a live demo and we'll see how that goes. So in terms of the Lightning Network, so firstly, it's a peer-to-peer network of payment channels, and it's implemented as a smart contract on the Bitcoin blockchain. So there's quite a few interesting words there. So the first is peer-to-peer. So that means that every node in this Lightning Network are equal. They all have equal functionality, and it's very much in line with how decentralized systems work. You have nodes with equal abilities, and then the other interesting point there is the smart contract on the Bitcoin blockchain. So most of us know about Ethereum smart contracts or other blockchain networks that have smart contracts, but Bitcoin also has some programming, some abilities for people to program with it. It has a very simple language, stack-based language that allows pushing and popping of very simple commands on a stack. And it's not a very sophisticated language, but nevertheless, it allows Bitcoin to be programmed, and that's what the Lightning Network makes use of it. And that's why it says it's implemented as a smart contract on the Bitcoin blockchain. So it's also a communication protocol that defines how participants set up and execute the smart contracts. And the good thing about Lightning is that it makes transactions instant, inexpensive, and also more private. So it's inexpensive and faster because it's not trying to settle immediately on the Bitcoin blockchain, and it doesn't have to wait for blocks to for the payment to be confirmed on the blocks. It's also a little bit more private because, as we know, in Bitcoin, even though it's cryptographically secure, you can see all transactions on the Bitcoin ledger using a simple blockchain explorer. And so in that case, in that instance, Lightning is a bit more private because you can't do things like that. You can't visibly see what's going on unless you're really, really great hacker, yeah. So in terms of the Lightning Network, there's normally 2 or more nodes involved, and they created a payment channel, and the payment channel will have some Bitcoin inside of it. Then the one participant, in this case participant B, will create an invoice, and participant A can create that can pay that invoice. And that's in a nutshell how the Lightning Network operates. So one of the features of Lightning is that this payment channel can remain up for as long as the participants want, and you can do micropayments, and it never has to interact with the blockchain, the Bitcoin blockchain, until the very end when the participants want to close the payment channel. So that's why Lightning is a faster and more cheaper alternative, because you don't have to settle on the Bitcoin blockchain until the participants are ready to actually close the payment channel. So you can do as many payments, even very small payments, on these channels as many times as you want, and as long as you have Bitcoin in the channel, until you're ready to terminate this particular channel. And so users of the Lightning Network can route payments to each other. So it's very low cost, and it's very quick as well, because you don't have to wait for blocks to be confirmed. And the users who exchange value of the Lightning Network do not need to wait for the block confirmations, and the payments don't need to be stored permanently. So there's fewer resources, and it's much, much cheaper than the Bitcoin method of payments on the blockchain itself. So once the payment of the Lightning Network has completed, it's final and it can't be reversed. So payments are transmitted to pairs of nodes and are visible to everyone, and has much greater privacy. It also uses real Bitcoin, which is always in the control of the user. So Lightning itself is not separate token or coin; it is Bitcoin, and it's a very nice addition to Bitcoin because of how quick it is and how much cheaper it is. So we'll move on to the architecture of the Lightning test network that I created on Amazon Web Services. So in terms of hardware, it was the Ubuntu Linux server, and it had 60 gigs of hard drive space, 1 CPU, and 2 gigs of RAM. So I used a Docker container. So Docker itself is a very nice setup in that you can use software that is already pre-configured and built in a container, and this container can then be deployed to something like a Linux server, and it will run, and the software will run without any further configuration. So all the setup work and everything is done in the container, and makes it very easy just to run it. So especially in terms of a test network where you don't want to spend a lot of time having to configure and to recompile software, it's very convenient to be able to use containers. So in my particular setup, I have a Bitcoin instance called Bitcoin D. So remember that the Lightning nodes do interact with Bitcoin eventually. So they do need a Bitcoin instance that they can interact with. And then I have 2 Lightning nodes, C-Lightning and C-Lightning 2. And these 2 nodes will have a payment channel in between them. And they all link together on a Docker network. So even though it's one single server, because we have different containers and because we're using Docker, we can actually get separate IP addresses for each of these containers and link them together. So you have a very nice local setup, not accessible by anyone, very safe because you're not interacting with the main Bitcoin network. The other feature to be aware of is that Bitcoin itself is running in this particular setup in reg test mode. So with Bitcoin, you have mainnet, testnet, and you also have a third option called reg test, which is more for local. It's more for local use of Bitcoin, where you don't want to interact with other nodes, but yet Bitcoin still will produce blocks, and you can do payments and have all the features, except that you're not able to interact with the other Bitcoin nodes in your local instance. And it's a nice feature that allows you to safely test Bitcoin in your own test environment. So we'll look at a little bit of Ubuntu commands. So it's a little bit technical, but just to understand what we're going to be doing in the practical session. So with the Linux system, it's very convenient to be able to use the command called sudo, which is a super user authority. So I use it all the time to execute commands, right? And then thereafter, you see there's a Docker statement. So that's trying to use functionality in your Docker container. So in this first command here, what I'm doing is pulling a Lightning container called LMBook from the Docker set of libraries. So I'm reusing a already set up Docker container in the Docker Hub, and this Docker container was set up by the authors of Mastering Bitcoin and Mastering the Lightning Network. So these authors set up these Docker hubs, and they allow people can freely use them to try and set up their test network. So I'm making use of that and pulling it down onto my server. Then the next command is creating a Docker network. So very simple Docker network create, and I gave it the name LNBook for my network. Then the next command is to then inside this network is to try and run Bitcoin and the two Lightning nodes. So this command runs it in the context of the Docker network. So then each of the instances running in the on the network will receive an IP address. You can see this is also a command, and this one will try and create the first Lightning network node inside the Docker network. Then if you use Docker network inspect, and you'll be able to see a list of all the nodes running in it, and you can see what the IP addresses of those nodes. So C-Lightning has a IP address of 172.18.0.3, and we can use this when we try to connect nodes together, etc. Other interesting command lines availability is you can use the get info on a Lightning node. Get info is useful because it can give you the ID of your Lightning nodes, right? So each Lightning node has a unique ID, very similar to a Bitcoin address, 256 hash encoded, and it allows you to identify the Lightning node, and it allows you to connect to that node. So very useful to use this command. Then when you want to connect one Lightning node to another, you can use the connect command. And as mentioned previously in the last slide, you use the ID of the node that you want to connect to, and also you can use the IP address and port. So the port is 9735, and that's the standard port you can connect to using network Lightning nodes. Then once you have your connection between your two nodes, then you can fund the channel. So funding the channel means that you can put some Bitcoin in your payment channel, and that allows the two nodes to send a little bit of Bitcoin to each other, right? But in this case, it's more a case of the first Lightning node being able to send some funds to the second Lightning Network node. And you can see in this particular command that I've written here, you'll see there's a 100,000 sat. That means 100,000 satoshis. That's the amount put into the channel. Right? So satoshi is the smallest unit of Bitcoin, and but the Lightning Network is good in that you can send satoshis and not like single Bitcoins only or something that's very expensive. You can send satoshis, maybe 1,000 or 100 or even less than that, because it's so inexpensive to send it on the Lightning Network. Then once you've got your channel funded, then so what happens is that one of the Lightning nodes has to create an invoice. So the second Lightning node will create an invoice for, in this case, 10,000 satoshis. And you can see I put two labels. I've called it invoice 2 and I've labeled it coffee. So it's documenting that I'm buying some coffee and sorry, not buying it, but sending an invoice for coffee to the first Lightning node, right? So this is the invoice created, and you want the first Lightning node to pay this. So this command is the pay command. So the first Lightning node, C Lightning, will pay the second one. You can see there's a very long cryptographic entry here. So that is basically describing the invoice and the node that the payment will be sent to. So that's how payment is done using this particular encrypted insert here. So that was the end of the PowerPoint, but now we can go into the interesting part of trying to understand our Lightning Network from a more practical point of view. So I am going to try and switch screens now. You can see that I'm doing multiple things at once, so I may not be doing very well in communication, but I'll do my very best. So I'm going to turn the screen share on. So the screen share takes a couple of seconds to load up, so I'm just going to wait for that. So I know that like it's very difficult to visualize, especially when it comes to the more technical terms, but I think for a better understanding of Lightning, it's good to be able to see it from a practical point of view, because it gives you that extra insight into how it works, even though sometimes it can be extremely technical. So I'm still waiting for the screen share to allow me to share the screen. It takes a few seconds, but this is some of the presenters' curse. If anyone has questions, maybe I can answer a few while I wait for the screen share to open up.
John?
Hi, Tony. Yeah, just
I think
maybe
let's
Sorry?
try stopping your slide presentation.
Okay.
I'm going to do that, right?
Okay.
And then maybe if you just want to try screen share again.
Okay, I'm going to turn the screen share on. Okay. Okay, I use window this time. Is that more or less visible?
At the moment, we got it. Yeah, I think it's coming up. So there we go. There we go. It's visible to me, which means it'll take a few seconds for the delegates to see it, but yep. Okay, they're confirming on the chat they can see it, John.
Okay, perfect. So the first thing I'm going to do is to start the various nodes. So this one here is the Bitcoin node. And I start the Lightning node. That's the first node, and I'm going to start the second node. So the next thing I'm going to do is to get information about the second Lightning, just to understand what its ID is, etc. Right? So you can see here, I'm typing very longhand, but just to force the understanding. But so I'm using the Docker command. So and it's executing commands inside the Docker container. And it's actually CLI is what executes commands on the very much Lightning instance. So what we can see here, so right at the top, we can see there's a ID. So that's the ID that you can use to identify this particular Lightning node. So this is my Lightning 2 node, and then there's also aliases and various information. You can also see the port is set at 9735. Also, interestingly, we can see the network is reg test, and that's the Bitcoin local test network. So that's very much different to the mainnet or testnet. So it's very much a local, more suited to a local test setup. Yeah, that's what it's designed to do. Yeah. So in terms of commands, what I'm going to do now is to actually create an invoice, and I'm hoping that will work. So what happens here is that the second Lightning node, you're going to create this invoice for the first Lightning node to pay. That's pretty much how it's initiated in a Lightning setup. Okay, so I've tried to create the invoice, but then it's reported back to me that I have insufficient incoming channel capacity to pay the invoice. So I actually have to fund the channel. So, and this is not planned, by the way. I actually forgot to fund the channel. So, so I'm going to use this command to fund the channel. So what I'm saying here is that I'm going to put 100,000 Satoshis in this Lightning channel. Hopefully the ID is still the same. Okay, so what I have to do, it couldn't find this particular channel, so I'm going to try and get the ID for this particular Lightning network. So you can see here that the ID of this node is this. So when I'm trying to fund the channel, I have to use this particular instance to try and. Okay, so I'm going to change this. That's my new ID. Okay, so this should work. Okay, I think this is a presenter's curse because it's not going to work right now. But essentially, with these Lightning Network nodes, you connect to each other using various channels, and then set up payments by creating invoices, and then sending payments via the invoices. I wanted to demo an actual payment, but I think I haven't set up the connection very well, so it's not going to work right now. But I think in terms of demo, I'll stop it right here, and then see if there's any questions that people want to perhaps ask at this stage.
I've got a quick question for you, John, while we're waiting for the others to decide if they've got something. This is definitely out of my area of expertise, but just a really silly question. I noticed on the command line information there that you were displaying, there's that long ID, and there was a very interesting alias with the name Yellow Spatula. Now, I'm not going to ask you where the name comes from. What I'm going to ask you, can you not access the that particular sort of reference via the alias? Can you only use the ID?
No, you can only use the ID because that's the unique address for the. And it's also cryptographically secure as well. So you always use the ID.
Okay. Sorry about the voice. And there's a question on the chat from Ashley, who asks, are there any security considerations or best practices to keep in mind when setting this up?
I think like in this particular setup that I showed on AWS server, its security considerations are not very important because you got it all local on your particular. So my AWS instance is not even open to the outside world. It's purely a test environment. However, if you're setting up for a Lightning node that's going to be used for practical and commercial purposes, so you setting up a Lightning node so that other people can make use of it and route their payments to, then there are a number of security considerations. I think the first is how you control and protect your private and public keys. So you got to have a very good key generation strategy that that ensures that you're always generating keys that they're well protected. You also have to obviously your server itself must be very secure and not having unnecessary ports open, and the normal considerations you'd have for protecting a server that's being used for monetary purposes. So that there's quite a number of things that would need to be put in place, but I'm not a real expert in that part of it. But yeah, there would be quite a few security considerations if you're running it commercially. But as I said, this is purely a test network. So my particular instance, I don't have any security concerns because it's not even accessible to the outside world yet.
Thanks, John. I don't see any other